everyone, I am Salamataba, a rising sophomore in computer science and interested in minoring in bioinformatics. In the past 10 weeks, I worked with Dr. Edward Kim from the College of Computing and Informatics on a project that involves using machine learning to predict breast cancer. I chose to work on such a project because of my interest in machine learning and its potential application in the medical field. As we all know, artificial intelligence is one of the fastest growing fields, and machine learning is a subfield of AI that is heavily focused on data and statistical models. Hence, it can have a huge impact in the healthcare industry by helping doctors make accurate prediction and make the best decisions. On the other hand, breast cancer is one of the most leading causes of death among women. And in the United States alone, more than 42,000 women die from breast cancer yearly. Worldwide, about 12% of women are affected by breast cancer, and the numbers are still increasing. If the cancer is not identified in the early stage, the result will be the death of the patient. However, if caught early, we can prevent those deaths. That's the reason machine learning and data science can come into the picture. However, the aim of my research is not to only train a machine learning model to predict breast cancer, but to also classify it as benign or malignant. First, to start this research, I collected a breast cancer dataset from the Wisconsin hospital. In this dataset, I had 569 patients and information about their diagnosis. Each row in the dataset had 30 different features that represented the mean, standard deviation, and the worst of different cytopathology measurements, such as the radius, compactness, concavity of the breast. I then studied this data by using a Python library named Pandas, and I cleaned it by removing irrelevant features such as the patient ID number. I then visualized the data to see how malignant cases were different from benign cases. I found that I had 252 benign cases and 357 malignant ones. By using a correlation matrix, I was able to see how each feature was related to one another. In the data pre-processing section, I split the data such that 80% will be trained and 20% will be used as a test. Once the data was cleaned, I started building the supervised machine learning models and compared them to see which one will give me the best accuracy. First, I implemented the Logistic Regression Model, which is a supervised learning algorithm used to predict the probability of a target variable. It is one of the simplest algorithms that can be used in classification problems, such as predicting breast cancer. It is a statistical model that is very efficient in finding relationship between features. When the model was trained, it gave me an accuracy of 97.36%. Then I implemented the naive Bayes algorithm, which is based on a mathematical theorem that assumes that the presence of a feature is unrelated to the presence of any other feature. This algorithm is efficient when having to deal with many features, such as the 30 features that I had in my dataset. However, it gave me an accuracy of 94.73%. Lastly, I implemented a KNN algorithm, which is K nearest neighbor algorithm, and is commonly used when dealing with classification problems because it works on the basic assumption that data points of similar classes are related to each other. When trained, it gave me an accuracy of 93.95%. Hence, I can conclude that among the three models, logistic regression is the best way to predict breast cancer with an accuracy of 97.36%. To see how my model performed the logistic regression, I used a confusion matrix to evaluate the accuracy. I found that in the testing data, which was 20% of my data, which is exactly 114 patients, it predicted that 40% were benign cases. Meanwhile, I only had 48 benign cases. It also predicted that 67 patients had malignant cancer when only 66 had malignant cancer. This tells me that my model is not perfect and still can be improved by training it so that it can give me a 100% accuracy. In the future, I would like to implement machine learning models such as support vector machine and random forest to compare it to my logistic regression model and see if it is still the most accurate. Thank you for listening.